Hello everyone, I am Dr. Ranganath Haridas, working as Assistant Professor in SVERI's College of Engineering, Pandharpur. Today we are discussing one of the topic related to physics. Its name is Communication Systems. So this chapter we have to check the basic terms related to communication systems, some concepts, equations, and then we will discuss some of the MCQs related to communication systems. So let us start discussing this chapter. So we start with the definition that what is meant by communication. Communication is the transfer of information from one place to another. This should be done as efficiently as possible with as much fidelity, reliability as possible, as securely as possible. Communication system components, subsystems act together to accomplish information transfer or exchange. So what is meant by communication and what is meant by communication system? So communication is nothing but the transfer of information from one point to another point. This should be done as efficiently as possible, then with as much reliability as possible, as securely as possible. Security is also one of the major point. A communication system is nothing but components or subsystems act together to accomplish information transfer or information exchange is called a communication system. So if we see the figure, that is block diagram of a generalized communication system. So there is a input information, that is information source. Then we are sending that message or signal to the system where three main parts are there, that is transmitter, channel and receiver. And then after receiver it goes to user of information. So if we see the figure, so information source, from that message or signal we are passing to the system, that is transmitter. Transmitter transmitted the signal, that is transmitted signal goes to channel or medium. So here channel or medium is different points we have to consider. Then from that medium or channel it is received by a receiver. That message or signal gives to user of information. So this figure gives us the idea or overall view of the communication system, how the important three things are there, that is transmitter, channel and receiver. So let us go to next one. So now we will discuss these points one by one, that what is meant by transducer, then transmitter, channel, receiver and then output transducer. So let us check it. Input transducer means what? The message produced by a source must be converted by a transducer to a form suitable for the particular type of communication system. Example, in electrical communications, speech waves are converted by a microphone to voltage variation. Next point is transmitter. The transmitter processes the input signal to produce a signal suits to the characteristics of the transmission channel. Next is channel. Channel can have different forms: the atmosphere or free space, coaxial cable, fiber optics cable, waveguide, etc. Different types of channels or medium we can use. The signal undergoes some amount of degradation from noise, interference and distortion. So we have to consider the noise effect while passing the signals. Next is the receiver. The receiver's function is to extract the desired signal from the received signal at the channel output and to convert it to a form suitable for the output transducer. Other functions performed by the receiver is amplification. The received signal may be extremely weak, so we have to suitably amplify that signal, removing noise, filtering and amplifying, and we can get the clarity of signal. Then demodulation and filtering. Next is output transducer. So it converts the electric signal at its input into the form desired by the system user. Example: loudspeaker, personal computer, tape recorders, etc. So let us see these points one by one. जर आपण फिगर बघितली तर इथं काय दिसतंय, इन्फॉर्मेशन सोर्स आहे ज्याच्यातून आपण इन्फॉर्मेशन पास करतो या सिस्टीम कडे, दॅट इज मेसेज और सिग्नल. ट्रान्समीटर ती माहिती ट्रान्समिट करतोय, ट्रान्समिटेड द सिग्नल to the channel. Through channel or medium, that information gets received by receiver. Receiver the information मिळवतोय and that receiver once again converts that signal into original format, that is block diagram. Now let us see the function one by one. Input transducer म्हणजे काय? The message produced by source must be converted by transducer to a form suitable for the particular type of communication system. म्हणजे फॉर एक्झाम्पल इलेक्ट्रिकल कम्युनिकेशन असेल तर स्पीच वेव्स ह्या कन्वर्ट केल्या जातात मायक्रोफोन मध्ये व्होल्टेज व्हेरिएशन मध्ये आणि त्या पाठवल्या जातात. नेक्स्ट ट्रान्समीटर. ट्रान्समीटर काय करतो? द ट्रान्समीटर प्रोसेसेस द इनपुट सिग्नल to produce a signal suits to the characteristics of the transmission channel. Transmission channel ला suit होईल असा इनपुट सिग्नल आहे तर तो कन्वर्ट करतो ट्रान्समीटर. and next is channel. The channel can have different forms. वेगवेगळ्या प्रकारचे चॅनल्स किंवा मीडियम आहेत. आपण ॲटमॉस्फिअर मधनं सिग्नल किंवा माहिती पाठवू शकतो. कोएक्सियल केबल आहेत, ऑप्टिकल फायबर केबल्स आहेत, वेव्हगाइड आहे. So these signals we can send through different channels. Then comes receiver. The receiver's function is to extract the desired signal from the received signal at the channel output and to convert it to a form suitable for the output transducer. Receiver काय करतोय तर ते desired signal आहे तर तो extract करतोय आणि ते चॅनल पासून घेतलेले सिग्नल आहेत तर तो कन्वर्ट करून आउटपुट ट्रान्सड्यूसरला पास करतोय. What is the role of output transducer? Converts the electric signal at its input into the form desired by the system user. जो ओरिजिनल सिग्नल आहे तर तो ओरिजिनल सिग्नल आउटपुट ट्रान्सड्यूसर आपल्याला मिळवून देतो. तर हे डिफरंट पार्ट्स आहेत कम्युनिकेशन सिस्टीमचे, ज्यामध्ये इनपुट ट्रान्सड्यूसर पहिला पॉइंट, दुसरा आहे ट्रान्समीटर, तिसरा आहे चॅनल, त्यानंतर रिसीव्हर आणि त्यानंतर आउटपुट ट्रान्सड्यूसर. तर यामध्ये इनपुट ट्रान्सड्यूसर कडून जी माहिती आहे ती माहिती ट्रान्समीटर कडे जाते. ट्रान्समीटर आहे तो सिग्नल चॅनलला पाठवतो. थ्रू चॅनल ती इन्फॉर्मेशन रिसीव्हर कडे येते. रिसीव्हर त्या सिग्नलला एक्सट्रॅक्ट करतो आणि आउटपुट ट्रान्सड्यूसर परत तो सिग्नल आहे तर तो ओरिजिनल इन्फॉर्मेशन मध्ये कन्वर्ट करतो. फॉर एक्झाम्पल लाउडस्पीकर, पर्सनल कॉम्प्युटर, टेप रेकॉर्डर etc. Okay, so let us move to the next one. Examples of communication system. So here there is a satellite communication, then another that simply the phonograph we are considering, that is records are there and we are using that records. So these are some examples of communication system. In case of first, that is for example satellite TV system is there, camera is recording the signals, then it passes to the TV station, then it transmits the signal to the satellite. So satellite is receiving and once again transmitting that to another satellite box, that is TV monitor, which is connected to TV monitor. and we are getting the original information as it is, like input transducer, that this camera and video shooting, this TV station is transmitter, then the transmission channel or medium is satellite, then another satellite box acts as a receiver, and output transducer is nothing but we are observing original information as it is through TV monitor. So basic modes of communication is like point-to-point communication. Communication takes place over a link between a single transmitter and a receiver, like telephone. Then broadcast mode, there are large number of receivers corresponding to a single transmitter, like radio and television. So radio and television all can observe at a time. So here large number of receivers we are considering, while for telephone it is linked between a single transmitter and a receiver. Now we have to discuss basic terminologies in communication. So let us check one by one. First is signal. So information converted in electrical form and suitable for transmission is called a signal. So signals can be either analog or digital. So we can have some figures related to these signals. So signal is nothing but the information which is converted in electric form and suitable for transmission is called as signal. So we are converting that into electric form and it should be suitable for transmission, that is called as signal. Next, transmitter. A transmitter processes the incoming message signal so as to make it suitable for transmission through a channel and subsequent reception, that we have discussed. So once again we are checking the basic terms. Transducer, any device that converts one form of energy into another is called as transducer. So electrical transducer, if you consider a device which converts some physical variable like pressure, displacement, temperature, force, etc. into corresponding variation in the electrical signal at its output. So it is the role of transducer or electrical transducer, we can say. Next term is attenuation, the loss of strength of a signal while propagating through a medium is known as attenuation. So when we are considering the communication system, so in that case we think that we are passing the signal from one point to another point easily, but it is not that much simple. So what we are doing when we are passing the system through channel or medium, whether it is a space, that is atmosphere, or cables, that is material thing, so losses are there for that signal, and due to that the quality of that signal gets changed. So depends upon that we are discussing this thing, that is the loss of strength of the signal while propagating through a medium is known as attenuation. Next, amplification. Amplification is the process of increasing the amplitude and also strength. So if the signal strength is weak or some noise effects are there, so we are amplifying that signal. So amplification is nothing but the process of increasing the amplitude and also strength. Next is noise. So noise is random, undesirable, that is unwanted electrical energy that enters the communication system. So because of some changes in the communication channel, this noise occurs. So noise is nothing but unwanted sound or unwanted signals. So it is a random, undesirable electrical energy that enters the communication system. Next is receiver. A receiver extracts the desired message signals from the received signals at the channel output. It consists of a pickup antenna to pick up signal, demodulator, an amplifier, and the transducer. So receiver is to extract the desired message signals from the received signals at the channel output. Then move to the next point, that is range. The maximum distance between a source and a destination up to which the signal is received with sufficient strength is known as range. So we are considering that what is the range of, for example, communication system. We are checking for mobile also, is their range is good or not. So if range is not available, then we are not getting audio video clearly. The maximum distance between 2 points, that is source and destination, up to which the signal is received with sufficient strength. So maximum distance is one condition, and second condition is sufficient strength we have to consider, that is the range. Next is bandwidth, the frequency range over which equipment operate, or the portion of the spectrum occupied by the signal is referred as bandwidth. So bandwidth is that portion or that frequency range over which equipment operates. So that is called as the bandwidth of that equipment. Next, modulation, the process of superimposing a low frequency signal on a high frequency wave which acts as a carrier wave for long distance transmission is known as modulation. So what is meant by modulation? So these two terms are important, that is modulation and demodulation. So modulation is the process of superimposing a low frequency signal. Our original information is there, so we are using that information and we are superimposing that information on a high frequency wave which acts as a carrier wave. So using carrier wave we are passing that signal, and that superimposition is nothing but called as modulation. That carrier wave carry that information for long distance transmission. So that is the important point. So now modulation we have checked. Now demodulation means what? The process of regaining of information from carrier wave at the receiver is termed as demodulation. So this is nothing but the reverse process of modulation. In this, the process of regaining means once again we are retrieving the information from carrier wave, of course at the receiver end. So it is termed as demodulation. So these are the basic terms. Once again we check what is meant by signal, that is information converted in electrical form or suitable for transmission is called a signal. Transmitter, which is transmitting the information or message. Transducer, converting the signals into desired form. Attenuation, that is loss of strength or signal. Amplification is nothing but increasing the amplitude or strength. Noise is unwanted signals which are came in this process. Receiver is nothing but to extract the desired message or signal or information. Range is nothing but we are getting sufficient strength up to the maximum distance between source and destination. Bandwidth is the frequency range of that equipment which operates in that range. And the last two is nothing but modulation and demodulation, where we are superimposing our original information on a carrier wave for long distance transmission, and in demodulation we are regaining or extracting that information from carrier wave to the receiver end, that is called as demodulation. Let us check some frequency bands, different frequency bands. So they are extremely low frequency. Its range is 30 Hz to 300 Hz. That's why it is called as extremely low frequency or ELF. Then voice frequency, that is 300 Hz to 3000 Hz. Then VLF, very low frequency, 3 kHz to 30 kHz. Then comes low frequency, 30 kHz to 300 kHz. After that, next range is medium frequency, 300 kHz to 3000 kHz. Next one is high frequency, which is 3 MHz to 30 MHz. Then we are increasing that level, that is very high frequency, 30 MHz to 300 MHz. Then ultra high frequency, which is 300 MHz to 3000 MHz. and last is super high frequency, which is 3 gigahertz to 30 gigahertz. So these are different frequency bands, and in that frequency bands different signals are there and different channels are there which are working under these various ranges, which starts from extremely low frequency and its maximum end is called as super high frequency. The next, some important wireless communication frequency bands, that is standard AM broadcast, FM broadcast, television, cellular mobile radio, and satellite communication. So if we consider this one, so television, it is VHF, very high frequency, ultra high frequency it comes. Then for cellular mobile, we are using the ranges in megahertz, and satellite communication in gigahertz, as we are passing these signals to long distances through atmosphere. So as we consider these radio signals and satellite signals, these are some important wireless communication frequency bands. So let us move to the next point, that is ground wave propagation is one of the point. Shading is radio wave propagation modes. So different propagation modes are there, that is the passing of signals from one point to another point. So first is ground wave propagation. So in case of ground wave propagation, it follows contour of the earth which can propagate considerable distances, frequencies up to 2 megahertz, for example AM radio. So when we are using the radio wave propagation modes, where ground wave propagation we are using, and in that this is the first one, so ground wave propagation below 2 megahertz. So here transmit antenna, signal propagation, that is channel or medium, and receiving antenna we are showing. So in ground wave propagation we are using these towers, that is transmitter and receiver, and we are using the space or atmosphere for signal propagation or channel or medium. Next, sky wave propagation, where signal reflected from ionized layer of atmosphere, that is ionosphere. Signal can travel a number of hops back and forth, example SW, that is shortwave radios. So here when we are considering the figure, so in that we are easily observing that what happens if we pass the signal in the space. So when we pass these signals, so they are reflected back from this ionosphere. So it is called as sky wave propagation, as it gets reflected from ionized layer or ionosphere. Then next is line of sight propagation, means transmitting and receiving antennas must be within line of sight, example satellite communication or ground communication. So in this case we are using the waves above 30 megahertz. So here the line of sight means we are transmitting and receiving antennas must be within line of sight, and we are sending these signals. So in space wave propagation, if we check, as we have discussed, the ionosphere is there, and if we send these signals, there is sky waves and ground waves are there, where we are passing these signals which gets reflected using this ionosphere. So earth and ionosphere, if we consider, so the cavity between these two acts as a waveguide, and from that we are passing the signals. The radio waves having high frequencies are basically called as space waves. These waves have the ability to propagate through atmosphere from transmitter antenna to receiver antenna. These waves can travel directly or can travel after reflecting from Earth's surface to the troposphere surface of Earth. So it is also called as tropospherical propagation. In the diagram of medium wave propagation, C shows the space wave propagation. So we are sending these signals at different heights, different style, and we are getting the transmitted and received signal. So another figure we are using, where we are considering ground waves, then sky waves, ionosphere and space waves are there. So communication satellite, for that we are using high frequency wavelengths, and for that high frequency we are sending these signal from one point to another point, where if you observe that ground waves are shown here near to Earth's surface, and high frequencies for this communication satellite, then these are called as space waves and these are called as ground waves. So let us move to the next one. So need for modulation. So what is meant by modulation? Superimposing of the original information, that is low frequency information on high frequency, that is carrier waves, is called as modulation. So size of the antenna or aerial. First point, for efficient radiation and reception, the transmitting antennas would have lengths comparable to the wavelength used. A vertical antenna of this size is impracticable, and hence direct transmission of such baseband signal is not practicable. So we are calculating the terms and we are getting the distance and the height of the antenna. Next, for need for modulation, effective power radiated by an antenna, that is according to theoretical study of radiation from a linear antenna of length L, the power radiated is proportional to wavelength lambda. Thus, for the same antenna length, the power radiated increases with decreasing lambda, or we can say decreasing frequency. Hence, effective power radiated by a long wavelength baseband signal would be small. For a good transmission, we need high power, and hence we will use high frequency transmission. So effective power radiated by an antenna is the second point. Mixing up of signals, different transmitters. So sound range, that is 20 Hz to 20 kHz, which is audible range. So all signals from the different sources would be hopelessly and inseparably mixed up. In order to separate the various signals, it is necessary to convert them all to different portions of electromagnetic spectrum. Each must be given its own frequency location. So that is the important one. This also overcomes the difficulties of power radiation at low frequencies and reduces interference. So in case of third point, that is mixing up of signals, different transmitters. Sound range, we know the audible range is 20 Hz to 20 kHz. So all signals from the different sources would be mixed. In order to separate the various signals, what is necessary? It is necessary to convert them all to different portions of electromagnetic spectrum. Each must be given its own frequency location. This also overcomes the difficulties of power radiation at low frequencies and reduces interference. So mixing up of signals, so different transmitters we are using, and mixing up the signals may confuse the things. Next is modulation. So signals to be transmitted are superimposed on high frequency, that is small wavelength, which are called as carrier waves. This process is termed as modulation, which attaches information to it. The information is then transmitted by radiating these modified carrier waves called as modulated waves. The modified carrier waves called as modulated waves. The carrier wave may be continuous or in the form of pulses. So in case of modulation, we have already discussed this, so superimposing the things. So carrier waves are there, which are called as modulated waves, and these carrier waves may be continuous waves or they are in the form of pulse. So here the pulse shaped signals and sinusoidal signals are shown here. So in this form we are using these waves, or pulse shape also we can use, where we can get the pulse duration, the pulse rise, pulse fall, and pulse amplitude, the time period and amplitude of sinusoidal signal. So let us discuss this modulation. So in sinusoidal carrier wave can be represented as, by this equation we can define it, where the C of t is nothing but the signal strength, that is voltage of current, AC is the amplitude, WC to phi FC is the angular frequency, and phi is the initial phase of carrier wave. During the process of modulation, any of three parameters, that is the amplitude, then angular frequency and initial phase of the carrier wave, can be controlled by the message or information signal. So here, modulation of a carrier wave we can observe, that is a sinusoidal carrier wave first, then a modulating signal second, then amplitude modulation, that is figure C, then frequency modulation, that is figure D, and phase modulation, that is figure E, we can observe. So first is sinusoidal carrier wave we are using, then modulating signal is there, then amplitude modulation we can observe, and we can add the frequency modulation and phase modulation also. So amplitude modulation is a process where the amplitude of a carrier signal is altered according to information in a message signal. The frequency of the carrier signal is usually much greater than the highest frequency of the input message signal. So if you observe here, carrier waves, that is amplitude modulator is there, modulating signal we are using, and after this carrier wave, that is superimposing the waves on carrier wave, we can get the modulated signal. So here some of the figures which can give us idea about this amplitude modulation. Next is carrier signal equations. So the carrier can be described in terms of a sine wave as follows. That equation we have just observed. In modulating signal equations, so modulating signal equation we can write as m of t is equal to am sine of wmt plus phi, where modulating signal frequency in hertz is equal to m upon 2 pi am is the carrier amplitude. Both am and phi can be omitted to simplify the equation by changing am to 1 or phi to 0. The next detection of these AM waves. So receiving antenna, received signal, then amplifier, then this IF stage, detector, once again amplifier and output. So this is block diagram of receiver, where we are receiving the signal through receiver antenna. These are suitably amplified, and after amplification we are giving that to output. Overview of these AM waves. So here modulator is there. So base band signal with frequency, that is modulating signal we are showing, that is source. Modulator is there. Next is channel, where band pass signal with frequency FC, that is modulated signal is there, and once again it gives to demodulator. In demodulator we are once again getting the original signal. So this modulation and demodulation is important process for or during this signal propagation or communication system. So if we observe the common applications, that is AM radio broadcasting, TV picture, video, two-wave radio, that is aircraft, citizens band radio, then amateur radios and military. So different applications are there. These amplitude modulation signals waves we are using for different applications. Then what are the drawbacks in these things that we have to check? So first is low efficiency, that is only 20 to 30% is useful because of low efficiency. Noise reception, this AM signal is easily affected by external atmosphere and electrical disturbances, that is unwanted signals mixed up, and we are not getting this signal clearly. So that's why we are using the filtering and amplifying noise removing things, and then we can get the original signals or original information. Then operating range is small. Then about quality, the allowed AM bandwidth is only 10 kHz, and for transmission of all audio frequencies about 30 kHz bandwidth is required, which affects fidelity. Due to limited bandwidth, stereotype transmission is not possible. So if we observe, some of the drawbacks are there, and due to its low efficiency, then it's catching the noise, then its operating range is small, and quality we check. So we have to work on that thing, and then we can use these things for the communication. So now we have to discuss some MCQs. So before MCQs, once again we recap the terms that we have started with. Some basic terms: that communication system, in that input transducer, transmitter, channel or medium, then receiver and output transducer we have discussed. Then by using figure, that is satellite communication case, we have considered and discussed that how you can observe the TV programs by using this communication system, where this input transducer, transmitter, then transmission channel or medium, receiver and output transducer are playing their roles. Then some basic modes of communication: one-to-one and large number of receivers. Then basic terminologies like signal, then transmitter, what is meant by transducer, attenuation, that is loss of strength, amplification, noise, receiver, what is meant by range, bandwidth, that is frequency range for that equipment, modulation and demodulation. Then we have discussed and observed the different range for frequency band. Then for different purposes we are using different levels of frequency. Then ground wave propagation, sky wave propagation, line of sight propagation, and this space wave propagation, where the waveguide acting between the atmosphere, that is we can say ionosphere, and the earth surface. Then this example of communication satellite, space waves. And what is need for modulation, we have discussed about size of antenna, then effective power radiated by an antenna, mixing up of signals for different transmitters. And once again we have discussed the modulation, sinusoidal or pulse shaped. Then in modulation we have observed some equations. What is meant by modulation, where sinusoidal carrier wave modulating signal, and amplitude modulation how it takes place. So this amplitude modulation we have discussed. Then carrier signal equations, modulating signal equations, detection of these M waves by receiver, that is block diagram of receiver. Then overview of this amplitude modulation, where the base signal or original signal gets modulated through channel, we are sending this modulated signal. Through demodulator, once again we are getting original signal. Some applications, and of course some of the drawbacks. So now related to this, some descriptive MCQs are there. So just one by one we can check these MCQs. The original electrical information signal to be transmitted is called as information or source signal, that we have discussed. The original electrical information signal to be transmitted is called as information, or it is called as source signal, that is answer D. Then next, major parts of a communication system are communication systems major parts are nothing but, answer is D, that is transmitter, receiver and communication channel. Three terms are there: transmitter to transmit the signal, then communication channel to pass the information, and receiver is to receive the things, that is signals. Next, the velocity of electromagnetic waves in a medium depends upon. So options are mechanical and electrical properties of the medium, then thermal properties of the medium, then electrical and magnetic properties of the medium, and last one is mechanical and magnetic properties of the medium. So electromagnetic waves, so answer is C, that is electrical and magnetic properties of the medium. So it depends upon these things. Next, in a communication system, noise is most likely to affect signal. So options are at the transmitter, in the channel or in the transmission line, at the receiver, cannot be predicted. So its answer is B. As we are discussing related to noise, we have just discussed in the basic terms that in a communication system, noise is most likely to affect the signal in the channel or transmission line. They are mixing up and they are distorting the signal. So answer B is the correct one. Next, a receiver of communication system consists of. So options are detector only, then amplifier only, detector, amplifier and speaker, detector, amplifier, speaker and modulator. So in case of a receiver, we are detecting the signal by detector, then the amplification and speaker we are using. So answer C is correct. Next, recovering information from a carrier is known as demodulation. So we have discussed just what is meant by modulation and demodulation. So demodulation is retrieving or regaining the signal once again from the carrier wave. So demodulation is the correct answer. Next, a microphone converts options are sound signals into electrical signals into sound signals, both A and B, and neither A nor B. So answer is A, that microphone used to convert sound signals into electrical signals. Then we move to the next. So which one of the following has the shortest wavelength? So different rays are shown here and we have to consider that which one of the following has the shortest wavelength. Options are infrared rays, ultraviolet rays, microwaves and gamma rays. So shortest wavelength means here we are considering high frequency. So gamma rays, if we consider the electromagnetic spectrum, so gamma rays are the rays which are having shortest wavelength. So answer for this is D. Next, the audio frequency range is from, so that we have discussed. The audio frequency for human being, of course, is 20 Hz to 20 kHz. Answer is B, which is correct. Then the audio signal, first option, can be sent directly over the air for large distance, cannot be sent directly over the air for large distance, possess very high frequency, none of the above. So we cannot send directly the audio signals over the air for large distance. So answer B is correct one. Next, audio signal cannot be transmitted because the signal has more noise. The signal cannot be amplified for distance communication. The transmitting antenna length is very small to design. The transmitting antenna length is very large and impractical. So D is the correct one, as audio signals we are considering. So it cannot be transmitted because its length we require, that's transmitting antenna length, is very large, so which is not possible practically. So answer D is correct. Next, in modulation, we separate the audio frequency signal from the carrier wave, superimpose the audio frequency signal over a carrier wave, separate the carrier wave from the modulated wave, none of the above. So twice thrice we have discussed the amplitude modulation. So to superimpose the audio frequency signal over a carrier wave is the correct one, that is B. Next, frequency modulation and phase modulation together is referred as, so it is referred as angle modulation, which is option B. So angle modulation is the correct answer, where frequency modulation and phase modulation together is referred as angle modulation. Next, which atmospheric layer absorbs a large portion of ultraviolet rays? So ionosphere, ozone layer, troposphere and thermosphere are the options. So ozone layer is the correct one, which absorbs large portion of ultraviolet rays. Next, the absorption of radio waves by the atmosphere depends on, so radio waves absorption by the atmosphere depends on their velocities, their frequencies, their distance from the transmitter, none of the above. So it is related to frequency. Answer is B. So the absorption of radio waves by the atmosphere depends on their frequencies. Next, an antenna is a device that converts electromagnetic energy into radio frequency signal, that converts radio frequency signal into electromagnetic energy, that converts guided electromagnetic waves into free space electromagnetic waves, and vice versa, none of these. So antenna that converts the guided electromagnetic waves into free space electromagnetic waves and vice versa, that is the correct one. So this is the last MCQ. So we have covered lots of small and important points related to this chapter, that is communication system. So in this communication system we have started with what is meant by the basic terms like transducer, input transducer, then transmitter, channel or medium, receiver and output transducer. Afterwards we have discussed the basic definition, what is meant by signal, attenuation, modulation, then carrier wave, demodulation, etc. Then we have discussed in detail what is meant by amplitude modulation. Afterwards, different applications of that amplitude modulation we have discussed. In case of communication system, that is different waves are there. So if we use the atmosphere as the guided media, that is waveguide, so we are sending this signal through atmosphere, it gets reflected back from ionized layer, that is ionosphere, and we are receiving these signals. For satellite communication we are using different frequencies. For that we have discussed the range of different frequency bands, plus we have added that for different application which range of frequency we are using, that also we have checked through the table. Then at last we have discussed the applications of this amplitude modulation waves, and we have added the losses related to this amplitude modulation, that we are not easily handle these signals as there are efficiency problems, then noise problems. Then we can use these signals by overcoming these terms. And in the second part we have discussed the different numericals, where we have observed different points related to the basic definitions that we have discussed, plus different scenarios for either space wave communication or either ground wave communication, plus we have added the different layers related to space, and in case of different frequency ranges, means for audible frequency range for human being, we have considered a case that can we transmit that signal or not. Then we have observed that if we send this signal at ground level and through the space, how we are getting the results. So I hope that I have covered some of the basic and important points, almost all the points related to communication system. So we conclude here. Thanks for listening and watching this video lecture. Thank you.